Hello everyone and welcome back to a new session for Computer Science 2. Today's session we're gonna go over polymorphism and virtual member functions from chapter 15. So polymorphism is, let's define it. So we're gonna speak about chapter 15, specifically polymorphism. So what is polymorphism? Polymorphism is basically the ability to allow an object reference or object pointer to basically execute different types and call the correct member functions depending on the type of the object being referenced. Let me type it for you. So polymorphism is the ability to allow an object reference or pointer. Let's say instead of object, there is to allow an or a base reference or pointer to reference different derived objects and call their respective member function. So this is the definition. It might sound a little vague, but it will make sense once we see an example. Basically, what polymorphism is, we're gonna take this example. Let's say I have the base insect, and then I have 4 children or derived classes. I have let's say it's a bee. Let's say I have a spider. Let's say I have boatman. And here I have grasshopper. So all insects have a name. All insects have, let's say, color, and all insects have. So this is a member variable. This is also a member variable. So these are like characteristics or attributes, and then I have a functionality. All insects move. So property, functionality. All insects move. However, a bee moves different than a spider, and a spider moves different than a boatman. So a bee flies. A spider jumps. I'm assuming it's the type of spider that jumps, just for the sake of this example. Boatmen, they live on the water, so they swim. Grasshopper jumps as well. Let's say instead of a spider, I'm gonna say it's a ladybug, so it walks. So ladybug. So ladybugs walk. So in this example, polymorphism is basically having a pointer to the insect. But this pointer references one of the derived classes. And then if I call move on this pointer, if this pointer is referencing a B, then the move of the B will get called and the functionality fly will execute. If the pointer references a ladybug and I call move on that pointer, then the walk functionality will get executed. Boatman, swim functionality will get executed. And if the pointer is referencing a grasshopper, then the jump functionality will get executed. So if I go back to the definition, polymorphism is the ability, or it allows a base reference or a pointer. So I'm gonna have a pointer to a base class, to a parent class. But this pointer is referencing different derived classes. So it might reference a bee or a boatman or a grasshopper. Remember the is a relationship? Because of the is a relationship, this pointer can reference a derived. Because at the end of the day, a bee is an insect. A ladybug is an insect. So I can have a pointer to an insect and it can reference a ladybug or a bee or a boatman. As long as it's a pointer. If it's a value or it's a it's not a pointer, it's an actual value, then it doesn't work as such. And I'm gonna show you an example. So the ability to have a base reference pointer. So I'm gonna have a pointer to an insect, but this pointer will reference different derived classes. Now, this pointer, because of the fact that it might reference different inherited classes, I can call a functionality and the respective version based on which pointer or based on what the pointer is referencing will get executed. So this is the example we're gonna work on. Let's go and write the code and build it and execute it. So let me grab my keyboard. I'm gonna go to my Visual Studio. So we're gonna have a class called insect. This has protected section and it has a public section. In the protected section, we have a string name. We have a int. I'm gonna say let's put it as a string as well. Color. Then in the public section, eventually I have a constructor, and I have another constructor that takes a string for the attributes. Then I'm gonna have a function that is not let's say display. This display has nothing to do with let's see, display, and then I'm gonna have a function called void move. Let's get rid of display just so I don't confuse you. So move is gonna be in the parent. So let me go ahead and define these. I'm gonna say there is a constructor here, and this constructor sets name to be empty and sets color to be empty. Another one is insect. This one takes a string a name, string a color, and it sets name to be equal to the a name and color to be equal to the a color. Then I have a move. I'm gonna say there is a function that is a void. It's in the class insect. It's called move. And this move, I'm gonna say see out. I am an insect. I move. I just move. General. I move. General. So we finished defining the insect. Now I'm gonna inherit from insect and give the first derived class. The first one we did is B. So I'm gonna have a class called B, public inheritance from insect. This B has a protected section, has a public section. In the protected section, what is specific to a B? Honey, so I'm gonna say, for example, quantity per month. So honey quantity. Quantity. Now in the public, I have a constructor. I have a constructor that takes an int. And then I have the move functionality. Void. Then I will define them. So I'm going to say there is a class called B. It has a constructor. This one will call first things first. So it will call the base, which is insect, and it will set its own honey to be empty, or not empty, -1. This will indicate that this is a default value. Then it has another one that takes a honey quantity, and this one will also take the ones for the base class, so string a name, string a color, and int. But it will pass to insect a name, a color, and it will use a honey to be honey. So a honey quantity. Here you go. So for the functions such as these specific, so it will take string int. Now for the move. The move, I'm gonna say there is a B move. This move will say I am a bee, I fly. And this is a void. So this is I'm an insect, I move. I am a bee, I fly. So this is done for the bee. Now I'm gonna do the next one, which is ladybug. I'm gonna copy these. I'm gonna say this is a ladybug that inherits from insect. Ladybug move. Takes these. What is specific to a ladybug? Specific to a ladybug. Let's see what Google says. What is special about ladybugs? Most people like ladybugs because they are pretty, graceful, and harmless to humans, but farmers love them because they eat aphids and other plant-eating pests. One ladybug can eat up to 5,000 insects. Wow. In its lifetime. Okay, so I'm gonna say how many so far? It's 8. So aphids count. How many did it eat so far? It takes an int and then it has a functionality move. So lady B, 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 and this one takes this bad boy, and this bad boy will become this bad boy, and this bad boy becomes this bad. Move. I am a lady bug. I walk. This is done. Now I'm gonna do the next one, which is a grasshopper. So grasshopper also inherits from insect. It has a constructor. It has the definitions. I jump. I am a grasshopper. I jump. What's special about grasshoppers? Let's see. Grasshoppers. They actually can fly. Because grasshoppers have such powerful jumping legs, people sometimes don't realize that they also have wings. Grasshoppers use their jumping ability to give them a boost into the air, but most are pretty strong flyers and make good use of their wings to escape predators. So what's special? I'm gonna say boost um boost what? Boost value? Boost value. Let's do boost value. Boost value. So boost value becomes this. This is just an example, and we are not really using the int because it's not our interest. Our interest is in the move. We're gonna show how creating an array of insects will execute different moves, and we're gonna see it on the screen. We're gonna see the difference by seeing that if the object is an insect, we're gonna see this. If the object is a bee, we're gonna see this. If the object is a ladybug, etc. If it's a pointer to a ladybug, sorry. So the type in Visual Studio is gonna be a pointer to an insect, but the content, oh, Visual Studio restarted. Did we lose? Did we lose work? For insect. B. Grasshopper. Good. So here we have boost value, I said. Okay. So in C++, in code, the data type of the container, our vector is gonna hold a pointer to insects, but we can store different derived objects in that pointer to insect. So grasshopper boost copy boost 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 save. So now this is ready. I jump. I also fly, but for now we're gonna say it jumps. This is done. This is done. This is done, and this is done. So I have these in place now. Now I'm gonna come here. I'm gonna say, remember dynamic memory allocation. Again, polymorphism does not work in a value. So for example, say I have an insect, my insect, insect. This insect is my insect, and color is black for now. Then I'm gonna have, for example, grasshopper, my grasshopper, and this grasshopper is my grasshopper. Color is green, and boost value is 10. I can, because of the is-a relationship, I can say this insect equals a grasshopper because a grasshopper is an insect. So I can say M insect equals L my grasshopper. And Visual Studio or C++ will allow me, again, because of the is a relationship. Because of this relationship, I'm allowed to do something like this. However, if I say L my insect dot move, look what I'm gonna see on the screen. Am I gonna see the move of the insect or am I going to see the move of the grasshopper? I am going to see the move of the insect because this does what's called slicing. Slicing means my insect has attributes, my grasshopper has the same attributes plus stuff. So it has the same attributes, it has a string, plus additional stuff. So slicing is taking the needed ones and ignoring the rest. So when you do this here on a value and not on a pointer, you're doing slicing, not polymorphism. You have slicing and you have polymorphism. Slicing is on the object or on an instance, and polymorphism works on pointers to instances or pointers to objects. So here we had a slicing. We basically took what we want from grasshopper and ignored the rest. Now my insect moves not like a grasshopper, it moves like an insect because it's an instance of insect. It's not a pointer to an insect. Now notice when I do an asterisk pointer and I do it as dynamic. So I'm gonna say this equals new insect. Now this is done. And I can say L my insect equals new grasshopper. I didn't really actually need the one. So I'm gonna say my insect is a new grasshopper. Now it takes a name. I'm gonna say my insect. I'm gonna say the color is black. And because I'm saying it's a new grasshopper, it needs a boost value. So I'm gonna say 10. Now notice when I do my insect move, this is a pointer, so I need to use the arrow. Notice here I'm about to do polymorphism. Notice that the type is an insect pointer. And because of the is-a relationship, I was able to say this insect is a grasshopper because a grasshopper is an insect. So I declared a new grasshopper dynamic and I gave it all the needed values. And I told this pointer to store the address of this newly created object. The new keyword allocates memory, right? It allocates memory, the needed size, and it returns the address. So I told this pointer to carry this address. And the address, inside that address, there is a grasshopper. And now I'm gonna tell my insect move. Now I'm still missing one important step. If I run, I will still see insect. Notice insect. Why? Because this move has to be declared, or basically, in other words, in a simplified word, I have to enable polymorphism on this function. I have to tell this function, hey, you are polymorphized. So I come to the base class, I go to the function, and I declare it as virtual. By declaring it virtual, I'm enabling polymorphism. I'm basically telling the compiler, you see this function, this might be polymorphized, right? This might reference other objects. So I need you to declare it as virtual. It has a definition of its own, but it's virtual. I would want to execute the different versions that are found in the oh, we're missing one more derived boatman. The ones in the derived. So I'm missing a boatman. Let's do it really quick. Mm, 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 mm. So let's do it here. Boat man or man? Was it a man or man? Insect. This goes here, 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 this goes here. I swim. What's special about boatman? What's special is they swim, mm, breathe, hold, period. I am a boatman, I swim. Okay, so back to this. Notice now that I enabled polymorphism on this function. So polymorphism is the ability to execute the version that the pointer is referencing. If the pointer is referencing a grasshopper, then the move of the grasshopper will be executed. If the pointer is referencing some other derived class, then the move of that other derived class will be executed. So notice now, when I execute, it's gonna tell me I'm a grasshopper, I jump. So although it's a parent class, the move of a derived class got executed, and this is polymorphism. This will allow later to basically agree, for example, between me and my teammate. Imagine there's another developer. I'm working on part of the software and they are working on part of the software. Let's draw it. I'm working on a component. I'm working on a component and this developer is working on a component. So this developer is working on a component of the software and I am working on a component of the software. There's a lot of work in this black box, and there's a lot of work in his black box. Let's say in that sequence diagram, this has to finish first, and then he sends me some data, and then I execute. So we meet, and at the design level, we meet, and we sit and we discuss, and then we agree that he's going to send me vector of vehicles pointer. Then in my functionality, I don't care what the vehicle is. Is it a motorcycle? Is it a car? Is it a truck? Is it a pickup truck? Is it a 4x4? I don't care. From my end, I I receive a container of vehicles, and if we want to move or anything else. If I want to move, we enable polymorphism in the move function of the vehicles. Then in my code, I don't need to check, hey, if the vehicle is a Ford or if the vehicle is a Suzuki, a motorcycle, Suzuki, or if this, or if that, then do this, then do this, then do this, then do. So if it's a Ford, move this way, or if it's a Suzuki, move that way, or if it's um a Mercedes, move that way. So instead of doing all this headache, we just simply enable polymorphism in move, and then I can just iterate that vector from 0 to end and call move on that object. As a matter of fact, it's an arrow. And call move. I don't care if it's a Ford or a Suzuki or a Mercedes, whatever it is, I just call move, similar to what I did here. Boom, call move. Did I need to do, hey, if it's a grasshopper, then move this way. Else, if it's a ladybug, then move that way. I didn't have to do all that headache. The fact that I enabled polymorphism, then I can just call move. And this pointer, whatever this pointer is storing, then the move version of that stored type will be executed. So that's why polymorphism is very nice and useful. So let's do another, let's expand or let's expand on this. I'm gonna say see out, enter your choice. Right? Enter your choice. I'm gonna say see out one insect. See out two B. See out three Boatman. See out four Grasshopper. See out zero Exit. Okay. Now I'm gonna prepare a vector of insect pointers, and I'm gonna call it my vector. Then I'm gonna say int l user input equals -1, and then while l user input is not 0, execute. Enter this, enter that, enter this, then I'm gonna switch on L user input. And if the case is 1, I'm gonna do something. If the case is 2, I'm gonna do something. Case 3, break. Case 4, break. And default just for the habit. And then I'm gonna push back. So here I'm gonna prepare insect pointer. L car pointer means current. And in case the user says this, then I'm gonna say insect al current pointer equals new insect. And in case the user enters 2, then current pointer is a B. Let's move this just so it's not annoying. In case it's a 3, I'm gonna say it is boatman. In case it is 4, then it is grasshopper. Default, I'm gonna say it's just a insect in case it's for whatever reason. So if the user enters 0, I'm gonna say case 0, do nothing, break, exit. Now, notice that I declared them as different. So B, boatman, one more, right? One more. B, boatman. What else? Ladybug. Forgot the ladybug. So insect B, 3, ladybug, 4, 5. So 1, 2, 3 is a ladybug. 4, 5. So 3 is a ladybug. In this case, it's a break. Breaking means going out of the loop. And if I go out of the loop, I want to display L my vector. As long as I am inside my loop, I'm gonna tell my pointer to populate. I'm gonna create this. And then once I populate, I'm gonna say L my vector dot pushback. Right? Pushback what? Pushback this bad boy. Now populate. I need to add populate. So in insect, I need to populate. Insects requires name and color. Grasshopper requires what did it require? Let's go and see. We required boost value. So let's start with insect. I'm gonna add void populate. It doesn't have to be polymorphized. So I'm gonna say populate. And then void insect populate. In populate, see out, enter the name. Cin into name. See out, enter the color. Cin color. So also in a bee, also in a ladybug, also in a boatman, also in a grasshopper. Now let's come here and say this populate in a bee. So this populate, I'm redefining, right? Remember redefining? So this populate is an insect, but I'm gonna tell B to redefine that populate. So B is going to first call insects populate and then see out its own stuff. So what do we require here? We require enter honey quantity. Cn m honey quantity. So now void populate, and here we're gonna say ladybug populate. We're gonna call the parent, and then this requires what? Enter count Cn into this guy. Again, for boatman, call this, and then a breathe hold period. So enter breath hold period. And populate is in here declared. Here it is, semicolon. And finally, grasshopper. So grasshopper will come here. We're gonna say populate, and this guy is gonna grasshopper call parent and boost value. Boost value. So back to our main. Notice if the user enters 1, 2, 3, 4, 5. Once the user enters it, I'm gonna call populate on this pointer. So if it's a grasshopper, the populate of the grasshopper will be called. Next, I'm going to push it to the vector, and then I'm gonna send this vector to a display function. So this display function, this display void display, it takes a vector of insect asterisk a vector. It doesn't like it because it is capital letter insect. Now I'm gonna just iterate for auto L item in a vector. This is a range-based loop. If you don't know what this is, it's in the book. It's called a range-based loop. You should know it by now. And then I'm gonna say L item, call your move. So this is what we agreed between me and my fellow developer. We agreed that his API or his component of the software sends me a vector of insects. Now I receive that general vector. I can do whatever I want in it without really the need to know what exact insect is in each item. I can just execute functions on it based on polymorphism. So let's try it. Let's break point in here before we go. So there is an error. What's the error? Potentially unsigned local pointer variable current pointer. Okay, so I'm gonna say this is a new insect just for the sake of the compiler. Start. So start, enter. I'm gonna say, I'm gonna put in order. First item, I'm gonna say, oh, why it's asking me for the name? I didn't enter my choice. So here, cn into L user input. We forgot that. Okay. So one. Now enter the name. I'm gonna say insect. Insect. Enter the color black or A or one. I'm gonna say. So now enter choice. Do I want to continue or do I want to exit? No, I want to continue. I want to enter 2. Enter for the B. So I'm going to say B. The color is 2. Oh, it didn't ask me for uh hmm. Let's see what's wrong. So this populate it executed only the parent, but it didn't execute the child. Oh, you know, we didn't enable um, polymorphism, so virtual. So now, if it's a B, then the populate of the populate of a B will be called. So 1. We don't need it anymore. So 1 insect 1. So now 2 B 2. Here it is. Enter honey quantity. I'm gonna say 10 or 22. So now ladybug. Enter the name ladybug. Color, I'm gonna say 3. Enter this, it's 33. So now I'm gonna say 4. Both men. Color is 4. 44. So now grasshopper. Grasshopper. Color, I'm gonna say 5. Boost value 55. So notice the questions are based on the type. However, when I enter exit, oh, interesting. While user input is what? While user input, oh, where's while user is that 0. Oh, populate is being called here. And this will enter an empty. So I should have said if a user input isn't 0, then populate and push back. I should have done this, but I didn't. So now it will populate and push in an insect. So I'm gonna say insect 6. So it broke. Let's do it again. However, let's enter a new line here. Let's do it again. Or here I can say if a user input equals 0, break, stop. So now I don't need to do this. So here break, otherwise do this. Okay, so let's try again. 1 insect, color is 1. 2 B 2 22. 3 ladybug, ladybug 3 33. 4 boatman 4 44. 5 grasshopper 5 55. So now I'm going to say exit. So notice the questions. The questions are based on the type, but the vector is vector of one type, which is the parent type. So a vector of one type, but each pointer in this vector references different derived class. One is insect, one is grasshopper, etc. So now notice when I step into move of the insect will get called for the first item. Then move of the bee will get called for the next item, etc. So continue. Here it is. So the first one is an insect, then a bee, then a ladybug, then a boatman, then a grasshopper. From a vector of insects, executing different versions of the function. And this is basically polymorphism. I hope it was simple. I tried my best to make it as simple as possible. Let me know if you have any questions.